Okay. Right. Okay. So once an Ethereum improvement proposal is accepted by the network, it becomes an ERC. And we're going to see three main ERCs today. There is no particular significance to the number of the ERC. It is just in the order in which it was accepted. So we're going to see ERC 20, which suggests that it's one of the earliest ERCs, just 20. And we're going to see 721, which came a little bit later, and 1155. Okay. So ERC 20 is the Ethereum token standard. So a very popular concept in Web3 is tokens. And we have used tokens in our Web2 world also, like maybe without actually knowing that we're using tokens. Anything from your reward points to like maybe your air miles, all of these are tokens. And let me just. Yeah. So this is the ERC 20 token standard. So this was once an EIP, which everybody accepted, and it has become an ERC. So if you want to learn any ERC, the best place is to come to the source, come to the Ethereum.org documents, and then go through everything that the standard is. Yeah, this is what I highly suggest. So what ERC 20 is a fungible token standard. What does fungibility mean? It means, I like to give this example. Consider a glass of water. And let's say you have an empty, another glass of water. Now I pour one glass of water into the other. At the end of it, would you be able to differentiate what molecules or what drops of water came from the other glass? You won't, right? It'll become a homogeneous mixture, and you won't be able to differentiate a molecule or a drop from one another. Fungibility is exactly that. When you have two tokens, they are identical in value, you won't be able to differentiate them. So if you, let's take money, for example. If I have $1 and $1 coin, or maybe it's a note, right? $1 note in one hand and another $1 note in the other hand. And if I swap it, both my hands have the same value at the end of the note. I'm not talking about, like the appearance of the note, or if it's a new note, or if it is folded in a corner, nothing like that, but the value remains the same. So that is a concept of fungibility. ERC 20 allows you to create fungible tokens. So this tokenization could be anything. It could be your money, it could represent a US dollar, it could represent the Indian rupee, it could represent anything, like even points that you win in a game, or if miles that you earn with your travel. It could represent coupons. It could represent anything where you have a bunch of tokens and you want them all treated equally. So that is the ERC 20 standard. And Ethereum said that I'm going to give you, if you're going to develop a token on your own on Ethereum, these are the functions and member variables and events that you have to include when you deploy your token. So that's why it's called a token standard, right? So if you go down in this page, please go through it. So these are the set of methods that a set of functions that any token on Ethereum should have. And these are the events that any token on Ethereum should have. So let's go through it one by one. First function that any ERC 20 should have is the name. Can someone drop some names of ERC 20 tokens that they have heard of? I'd love to know what you know of ERC 20 so far. Any ERC 20 that you own, or you've heard of, or you've traded with in the past. Can you drop some names in the chat? Awesome. Right, definitely. Yep, Bitcoin is a very famous one. Yep. Uni is also a good token. So Uniswap token. ETH is also as the native token. IRC. Right. So good ones on the chat. So all of these tokens, except maybe ETH because it is the native token. But you have a wrapped ETH, which is a ERC20 format of the native token, will have these functions. That is, you can invoke these functions on that token. The first one is the name. Of course, it's the name of the token. You can put any string to it. It will return a string value that you associated with. The symbol is what you guys have put on the chat, ETH or UNI. And ApeCoin is the name. So it'll have the APE, I guess, is the symbol for that token. So most of our currencies, like we have the dollar sign or the rupee sign or the euro symbol or the pound symbol, right? So these are symbols that you can't directly type in here. So they give you a 3 or 4 letter abbreviation that you can use as symbols for the token. So this is also a string that represents the token. Decimals tell you the lowermost denomination of that token. For example, for $1, we have the lowest denomination as cents, right? 100 cents make up a dollar. We also see, we saw that in other currencies also, 100 paise make up 1 rupee, 100 pennies make up 1 pound. So similarly, we can we can customize the denomination that we want our token for. Ethereum allows up to 10 power 18. That is the lowest denomination that you can go to, because one way, 10 to the power of 18 way makes up 1 ETH. So this is the decimals that define the lowermost denomination you can use for your token. Total supply. In a ERC20 contract, the total supply function returns how much of that token is in circulation across the blockchain, right? Total. So this can be done in 2 ways. You can keep minting more tokens, which increases the total supply. But at any point of time, it will return the total amount of tokens that is there in the blockchain. Or you can decide how much tokens you want to mint at the beginning. At the constructor level itself, you can say, I want 100,000 of these tokens in circulation. I don't want any more, any less. This is also an up to you as the token designer. Whoever is deploying the contract has the say in how he wants his economics to be regarding that token. Right? Balance off. Balance off is another function that takes an input as an address. It takes an address input and it returns an integer balance. So that means if you invoke balance off function with an address, it will return how much balance this address owns in this contract. So let's say that this you're creating a contract for your own currency. Let's say you want to bring in your own currency. I have an Ovia currency and I maintain a list, an array of all the people who own Ovia tokens and how much they have. So when I invoke the balance of function with an address, I will just simply return the balance of Ovia tokens for that particular address. So this is the balance of function. Transfer function is when you, if I invoke the transfer function, I will basically be sending this token, if it is Ovia token, from my address to the person I want to transfer to and how much I want to transfer, right? And it will just return a success or a failure if the transfer has gone through. Note that this transfer is not the same as the native transfer that we spoke about, the value transfer transaction. That is only for the native token transfer, and the value goes with the call data. It is one of the call data. This is considered a function invocation transaction. So this is a key difference that you have to note in ERC20. ERC20 is a contract that represents a token, so that you're talking about the transfer of this token, not a native token. A transfer from is when you want to transfer on somebody else's behalf, right? You want to transfer from this address and to this address, and you are a third party in this transaction of this much value. So to do this, you might wonder how can I just transfer on somebody else's behalf, right? obviously they should allow me to transfer on their behalf. So a transfer from function is always accompanied by an approve function. First, an approve function has to be invoked where a person assigns some control of some of their balance to me. So the spender is me. Somebody else who owns the token should assign this much value to me to spend on their behalf. So this is not transfer. I'm not getting this value to my address, but this value is there in the original owner's address. But he said that I have permission to use up to this much value at a later point of time. Right? So this is what approve means. So after approving, I can, as a third party, I can use the the person who called the approve function as the from, and to any person up to the value that I've been approved of. So this is how I use the transfer from function. Again, it returns a success or a failure. Right? Allowance tells me that if somebody else has approved some amount to me, I can use allowance to read how much allowance I have left. If I've already used some of my allowance in transfer from functions, how much of the approved amount can I use, do I have left to use, is my allowance. So these are very straightforward. They're not very difficult to understand. So these are all the functions that a ERC20 token must have. Apart from that, they should have two events. As I said, events are a way to log what is happening in the blockchain. So every time a transfer function is invoked, transfer function will return a success, but it will also emit an event which basically says from this address to this address, this much value has been transferred. This goes out to everybody in the blockchain as an event. Event is not the same as a transaction. It is just a log of a transaction. So the transaction is basically the invocation of the function, which is the transfer, and it has one output like we saw earlier that just comes in the JSON result of that transaction. Right? And approval, every time the approve function is called, this is also returns an event saying this owner has assigned this spender this much value to transact at a later point of time on their behalf. So these are the main functions that we need to understand in a ERC20 contract, right? Okay, so let us quickly go to Etherscan and see some popular ERC20 tokens. So this is Etherscan. Just excuse me 1 minute. Yeah, sorry about that. So in this, I've come to Etherscan now. It is in Sepolia Etherscan, where we won't have many of the tokens. So I am going to go to main Etherscan, which is where I'll just remove this Sepolia prefix. So this is the main Etherscan of the Ethereum mainnet. So here, so you can see all the transactions that are happening. This is on the Ethereum blockchain. So if I go to tokens, when I say tokens, it basically means whenever you hear the word token, you can assume, with respect to Ethereum blockchains, EVM-based blockchains, you can assume that it is an ERC20. For sure. That means it will have all the functions and the events that we discussed. So if you see, these are very popular tokens. Many of them is what you guys already mentioned. USDT is a very popular stable token, which means it's a token that will always correlate with the US dollar. So one token that is minted on the system will have $1 reserve somewhere in our real life. Right, so those are stable coins. We haven't discussed many of the DeFi topics. Maybe this is a good topic to consider for future sessions by Women Who Code. But yeah, so these are different tokens that I have. You can that are present. As you can see, Etherscan has ranked USDT as the top token. That's because the categorization comes from different factors on how much its trading rate and its liquidity. Liquidity means how much of these tokens are present in a pool. So based on several factors, it makes this ranking, but it can keep changing. So we have USDT, BNB, USDC. These are all tokens that are there on Ethereum main chain, and they're all ERC20 tokens. So I can open any one of these. Let's say I open USDC, right? So USDC is a verified contract. So that means we tried verifying in the previous session and we were unsuccessful. Let's try it again today. Please remind me at the end. So in a verified contract, the advantage is we can read the code of the contract, and we can also play with the functions. So, sorry. What does that mean? Okay. Yep. Okay, so this is not verified properly. I mean, or I'm not able to see the exact. Let's look at some other ERC20 token. I think it's not verified properly. So let's look at USDT. Yeah, so this is also a verified contract. And if you can see, this has all the functions that we spoke about and some more. The criteria of a ERC20 standard is it should at least have the functions and events that we discussed. So you can see things like balances, which I think is balance off. It's the same as balance off. You have total supply. You have, so these are all read. So the read functions are categorized, are there in the read section, and then the write functions are which change the state of the blockchain, which is there in the write. So things like transfer from, transfer ownership. Transfer ownership is not a part of the standard, but it is an additional feature that this ERC20 is giving us. Right? So yeah, approve. So these are different things. So you can see that the total supply of USDT token is this much, which is a lot of money. That means the person who has built this contract has this much US dollar, because it's a stable coin. Each of these tokens should have a corresponding reserve somewhere. This much US dollar in some kind of treasury that kind of maintains the balance between the USDT tokens circulating on the blockchain and it's off ramping into the real world. So yeah, that was interesting. So let's move on from ERC20s into ERC721s. So the difference between ERC20 and ERC721 is that ERC20 is a fungible token standard, and ERC721 is the first non-fungible token standard. So while with the gaining popularity of Ethereum, this ERC721 is still a very small number. So this also came like much early in the stages of Ethereum. So this gives us the standard to define a non-fungible token, right? Let's look at. So the perfect place to understand it is again in the Ethereum documentation. So how do I understand non-fungibility? So think of it as a token, but it has unique properties. So if I give you two tokens, there are unique things that differentiate them. If I swap them, then the value is going to change, right? Each token has its own attributes that differentiates it from all the other tokens. So that is what a non-fungible token is. Again, Ethereum has specified specific functions and events that we need to implement in any ERC 721 standard. A good way, before we see these functions, let's see an example of an NFT. You can again go to Etherscan and look for the top NFTs over here, right? Or you can go to NFT marketplaces. So NFT marketplaces are good, like you have DEXs, decentralized exchanges to swap tokens, to buy and sell tokens. You have NFT marketplaces to buy and sell NFTs, right? So one very popular marketplace is OpenSea. Oh, okay. Yeah, OpenSea is a very popular marketplace for buying and selling NFTs. Again, you can connect to your MetaMask to buy NFTs. Okay, this is not working for some reason. Okay, let's go to another marketplace. Cool, this is working, right? So Rarible is another marketplace for NFTs where you can buy and sell NFTs. So you might have seen in the past, news in the past for about an NFT selling for millions of dollars. And I wouldn't blame you if you've wondered what makes it so valuable, right? So imagine you're an artist or somebody in the creative line, and you have created some kind of digital art or some piece that you want to sell, right? So in early days, you would maybe host a gallery, like put it up in a gallery, or like have an opening where people can come and see your artwork and bid for it. And you have a limited audience in that setting, and it mostly goes by word of mouth. And once you sell this NFT, you have sold it to one person. You have basically relinquished rights over it, and the new person will own that piece of art. And this is a lot of your time and effort that is going into that piece of art, right? So here, this NFT, even though you can replicate it, it is a digital format. So the actual artwork can be replicated, but the ownership can be tracked. And any rewards, you can put any logic on how you want the control of your artwork to be. You can choose to relinquish complete control over your artwork, or you can say that I will always own 10% of this. And if you want to sell it to the next person, then I should get some profits of the next sale also. You can put any logic that you want. And these are advantages that NFT gives. You can uniquely identify the ownership on the blockchain. So many people put profile pictures as NFTs, like one very popular NFT was the Bored Ape Yacht Club, or even CryptoPunks. CryptoPunks is one of the top NFTs over here, if you can see. So basically, it is just a piece of, it's just a very simple kind of GIF image with different faces. And this started selling for millions of dollars. So this NFT is it became kind of a utility NFT. The example that I just mentioned was for the art domain, but NFTs can be used basically anywhere. Wherever you want a token to have some unique properties and to give unique value to the person owning that NFT, you can use an NFT. Think of concert tickets, right? If you're hosting a concert, you can give one ticket to one person as an NFT. And they have to prove ownership. That is, they have to have that NFT in their wallet to enter your concert. These are kind of utility NFTs, where you're using them for a purpose. Or you can claim attendance, for example. I attended it. You can also use that ticket NFT as an attendance to prove that you actually went to that concert. So these are called POAPs. POAPs are not exactly NFTs, but yeah, the concept is the same. So after you enter an event, they can mint an NFT for you. And using that NFT, you can say that, yeah, I definitely attended that event. think of your degree certificates, your academic certificates. All of that could be NFTs that are very unique to you. Your educational institute has minted and created these NFTs that you hold in your wallet that nobody else can take from you. So these are like soul-bound NFTs. Only you can have them. You can't. You shouldn't transfer them to anybody else. So they have so many utilities, actually. Like anything you can think of in this world where there is some unique property, you can mint as an NFT. If you have any doubts about NFT, please feel free to ask. I see that there's a question: what would make someone choose one token over another? That's a great question. So there's nothing that, it's just basically, why would you buy something? Like, why would you, let's say you're investing in stocks. Who is making you buy some stock where maybe it's high trading rate, or you think that there is some buzz around something and the stock price is going to increase? That's why you would buy that stock, right? Similarly, tokens also function the same way. If people think that, its value is going to rise, then many people try to buy many of those tokens. Yeah. But again, like the stock world is also predictable to an extent. I mean, at least it is related to real world events, but crypto is not related to anything like that. Maybe if Elon Musk puts a tweet, then you can see some rise, but that butterfly effect is very minimal. And it is very volatile. So any token can rise or fall at any point of time, and you should not go by any word of mouth. Do your own research and then invest or buy in your tokens. Yeah, coming back to NFTs. So this is a kind of NFT. So a cool purpose that came about in this NFT is token gating. So a community kind of formed around this NFT. Everybody who held this CryptoPunk NFT were kind of formed like this elite group. So any events, only if you have that NFT, you can enter it. It became like a token for entry. So yeah, so I honestly don't know why some of the NFTs are selling at such high rates, but that's the reality of it, right? So each NFT, so basically this is an NFT collection. All of these NFTs were minted from the same contract. So you have one ERC20 contract, and it has several token IDs. Each ID is one of these NFTs. Each ID has a different property. So the property of this NFT may be like pink glasses with blonde hair. This property may be blue glasses, red nose, and gray hair. This could be like a black mohawk, no beard. This could be like a pirate's cap. So there are different properties for each of these NFTs. We can actually maybe even read them. Let's just see, right? Open view. Okay, so now for this NFT, it has been sold to this user, I believe, or it has changed. Who owns them? Yeah. So the creator of this NFT is this person, this wallet address, and the current owner is this wallet address. So this NFT has been changing hands, and this is the current owner of this NFT. And you can even see on Etherscan what is happening. So let's first view this collection. So all of these CryptoPunks NFTs have been created from the same ERC20 standard. This is the standard, right? Okay, this is CryptoPunks. Let's look at so these are the properties. So you can see all the properties that it has, right? Hair, eyes, beard, sex, mouth, lips, neck, emotion. So these are all the ways in which these NFTs are differentiated. So you can even, if you want a particular trait that maybe looks like you can even, say, red hair or something. So there's vampire hair. So if I search for that, so these are the NFTs that comes with vampire hair. So this is one way you could maybe look at an NFT. So let's say if I open this NFT, let's look at it on Etherscan. Okay. So this is an ERC 721. We know it is an NFT, so why should they specify that it's an ERC 721? We'll come to that very soon. So this is the ERC 720. This is the particular NFT that we saw. So, right. Okay. So we saw the price of this NFT is $2,155, you guys. Just one, this GIF, this pixelated GIF image is costs so much. So let's go to the NFT contract. This is the NFT contract for CryptoPunks V2. So you can see that so many transactions have happened. We're more interested in what this contract says. It is a verified contract, but I'm not able to see the read contract and write contract functions. But no worries. Let's go to our ERC 721 standard again and go through these functions. So again, all NFTs are created using the ERC 721 standards, and every NFT standard must have these functions and these events implemented in it. So the first function is the balance of. Again, it is very similar to the ERC 20 balance of, where in ERC 20, we gave an input address and we received how much of those tokens, that ERC 20 tokens, a particular address has, right? So here again, we input an address and we get the number of NFTs from this contract, from this collection. So each NFT, so we saw that this CryptoPunk, right, is a collection of NFTs. So it has a lot of tokens. So it has a total supply of 10,000. So there are 10,000 possible NFTs in this collection. And how many of those CryptoPunks tokens we have, that is returned by this balance of function. It doesn't specify which exact token IDs you hold, but the aggregate, this total count of all the tokens is returned to you in the balance of function. The owner of. If you're looking for a particular token ID, for example, let's go back to CryptoPunks, and this is the token that we're interested in, and this has the token ID 9,968. So if I'm looking for who owns this particular token ID, I could just enter this token ID and it will return the address that that holds this token ID. So basically it should return the current owner, this person, Abigar Max. Okay, so this is the owner of function. Save, transfer from. So these are all very similar functions. So I'm just going to explain transfer from. Save, transfer from just gives you one additional check, which I'm not going to get into right now. So transfer from is very similar. It basically transfers one token ID, a particular token ID, on somebody else's behalf. You're transferring it from their address to somebody else's address. Again, whenever you have transfer from or save transfer from, you need to have an approve. That is, that person should have first said that you are allowed to transfer this token on my behalf, right? So this approve function should have been done before you invoke a transfer from. Set approval for all means that so you're approving one person for control over all your token IDs, right? Get approval means if for a token ID, the person who's invoking, you can see whether you are approved to transact on that token or not, because only one address can hold one token ID. One token ID can only be held by one person. It cannot be held by anybody else for a 721 contract. Right? Okay, is approved for all is just checking whether for a particular owner, does this person, operator, have the approval for all his tokens or not? Approval to transact on all his tokens or not? So this is a read function. This is also a read function. This is a set function. This is also a set function. So every time a transfer happens, every time a transfer happens, an event is emitted. Every time an approval happens, an event is emitted. And every time approval for all happens, that at that time also an event is emitted. So difference between approval and approval of all is approval. You can approve one person to transact on your behalf for one token ID. Approval for all is you're giving permission to one person to transact across all your token IDs. Okay, this is just like a batch approval for all the token IDs that you own and you may own in the future. Yeah, so that is it about 721. So the 721 was pretty cool. It came and it saw a surge in transactions on Ethereum. People started doing really cool stuff. There was crypto kitties, crypto zombies, crypto punks, board ape yard club. You guys must have seen this. So Board Ape Yacht Club is a very, again, it's a token gated community for all the, okay, I'm not allowed. Maybe I can search for it here. Yep. So these are the different, this is the Board Ape Yacht Club collection. These are all the monkey emojis, not emoji, NFTs that you might have come across very often. Right. So, so once we started, NFT collectors became a big thing. People wanted to collect NFTs, and we saw many utilities also for NFTs. How we can use NFTs for a much wider range of applications, like I just said, like event ticketing or many other things, right? So there was a lot of problems in using this ERC 721 contract, right? For example, you can't do batch transfers. Every time you need to transfer an NFT, you have to do it token by token ID by token ID, right? And for every collection, for everything, you have to create a new contract, right? So it became a problem for people. Think of, let's say you're developing a blockchain game where you have your character who can do a lot of things. They want to collect some health points. Health points are fungible tokens, right? The two health points are similar to each other. They're not distinguishable in terms of value. So health points are fungible tokens. Then you have like gold coins he may collect. Or he can collect, let's say he has this exclusive challenge, and once he completes it, he gets a cloak. And the cloak is very unique, so that becomes an NFT. Or if you have a online multiplayer game, let's say that only few people are eligible. Whoever have achieved, let's say a battle, who've won some battle, they get that cloak, which is a very elite object in the game. And that is an NFT that you can't really give other people. So would a person want to maintain so many contracts for like for health points one contract, for gold coins one contract, for cloak one contract, for sword another contract, maybe even articles of clothing, just normal articles of clothing that that change avatars, right? That lets you customize your appearance on a game. So these are also tokens. Either it could be fungible tokens or non-fungible tokens. So people wanted fungibility as a spectrum, right? When there is one, if you have plenty available, let's say you have like thousands and thousands of tokens available, then of course it's a fungible token. But if it's very unique, then you just have one of that item, and it's very elite, then it is completely non-fungible. But there's also a concept of semi-fungibility when there is not much in circulation, like limited supply. So it is fungible because there are more than one copies of the same thing, but it is also non-fungible because it is limited, right? So people wanted to see fungibility as a spectrum, and they also wanted a way to maintain all of these tokens under a same contract instead of having so many multiple contracts for the same application. And also they wanted to save gas fees by doing batch transfers. Instead of doing one transfer at a time or one approval at a time, they wanted to do batch transfers and approvals. So this is why they moved to the ERC 1155 standard. So let's see what that is. right? So this is a multi-token standard. Again, I would highly recommend that you go through the actual documentation to know what it is. So ERC 1155 is a standard where if you're going to implement this, it's basically a fungible and non-fungible multi-token standard. You can declare many fungible tokens and non-fungible tokens in the same contract, and you can even decide your spectrum of fungibility, whether you want it to be fully fungible, just one of that item, or somewhere in between, a semi-fungible range. Okay, let's. Let's go. Yep. So semi-fungibility has not much difference from the ERC 721 standard. I would say it's just an extension of the 721 standard. So, but it has some extra functions for batch transfers, right? You can do batch transfer from and batch approvals, right? Yeah. These are the only two differences from the standard. So I'm just trying to see if we can get an article or an example contract. Okay, let me just stop my share for a minute. Sorry about that. I'm just trying to find a contract that we can use. Okay. Let me share my screen again. Okay, so I'm just, you guys can also see what I'm doing here. Okay, this is a really good one. I hope you can see my screen. Okay, so Open Zeppelin is a company that creates libraries for many things, and one of it, they have great libraries for Solidity, and they've created excellent templates that are kind of gold standard. Everybody uses them for all of the standards that we just spoke about. And we will also use them. I'll do a demo session right after this. So in ERC 725, they've kind of explained in their docs. So just go to docs.openzeppelin.com. So here they've given an example of a contract game items, which is a ERC 1155. So it has inherited from the ERC 1155. So basically all the functions is that you need to have in that standard is already there here, right? So it has gold. So each item, each kind of NFT that they want, they have assigned it a constant named 1, 2, 3, 4. And when they create this game items, they invoke the constructor over here, and they mint so many of those items. So they whoever has invoking the constructor or who's creating this contract, they get gold of 10 to the power of 18 minted to them. So that obviously that means it's a fungible token. Gold is a fungible token, and silver is also fungible token. They're minting to 10 to the power 27 to them. The Thor's hammer is only one. They're just minting one. So this could be an NFT because it is very unique. Sword is 10 to the power of 9, which is also fungible. Then shield is also 10 to the power of 9. You could also have things like just that can have like, let's say, special cloaks that are in circulation, and only selected players can get access to them. You can just mint like 10 or 100 of those tokens. So they can be semi-fungible. So that's how they get the range of fungibility that I was talking about, right? Right. So all the other functions that we discussed for 721 applies here also. So how do you create these fungible and non-fungible token standards? So I would, okay, so what you can do is you can go, let's use OpenZeppelin because that is the, you could also create your own thing. You already know what functions you need to implement. So you can go ahead and create your own contract, but the standard industry practice is to just inherit from the existing libraries. So you can go to OpenZeppelin wizard. So Zeppelin Wizard is a very nice interface where you can create your contract. So it allows you to create ERC20 tokens, ERC721 tokens, ERC115 tokens, governance tokens. So let's create a ERC20 token. So you can give the name for your token. Let's say I want to call it Ovia token. Okay. And I can give my own symbol to that token. As you knew, we saw that ERC20 has name, symbol, decimals. So I'm going to say it is OVT for Ovia token. And pre-mint is how in the constructor, how much do you want that tokens to your address in the beginning? So I'm going to just mint about, so much. I'm going to mint about 1,000 into 10 to the power of 18 is the standard denomination. So, okay, Mintable says, do you want to mint more of these tokens at a later point of time? So it will give you the mint function. So in our ERC1155, we saw that in the constructor, we were able to mint this thing, right? So that basically invokes the mint function. Here also you're invoking the mint function. But here it's giving me another mint, which overrides the mint from the other contract, which will let you mint more function. And as you can see, it's creating, as I'm clicking these boxes, it's creating functions for me. So all you have to do is just get like a nice template based on the features that you want, and you can add your custom logic to it at a later point of time. Burnable, do you want to completely destroy these tokens at a later point of time? You can add a burnable. And so they're just basically importing contracts as in when you want them. Possible. Do you want to pause the minting process at some later point of time? Do you want there to be a point where nobody can mint more of these tokens for a set period? That is possible. Permit votes, not quite sure what they are. I guess these are governance related things, flash minting, snapshots. Let's not go into too much complexity. Okay, I've given this as ownable. That means one person can own it, and basically I will own it, and you can transfer on, or you can have roles. If you do roles, okay, let's not complicate. Okay, let's just keep it ownable. That is, I have the only owner function. Let's not go into upgradability. That's also an advanced topic where you can change. I kept saying that once you deploy smart contracts on the chain, you cannot change it, which is true. But what if you have a bug or something and you do want to update the code? So there are different standards or design patterns you can use to keep your code upgradable at a later point of time, but you have to decide it at the beginning. So I'm not going to talk about that. You can choose what license you want. It's automatically given me an MIT license and the current stable version of a Solidity compiler. So cool, this looks good to me. I have my Ovia token, which is an ERC20. It's burnable, possible, and ownable. And it has a constructor. It's given me a pause function. Maybe I'll just remove this pause function. And it's given me a mint function where I can mint it later on. So I've created my own token and I wrote 0 lines of code. So let's see if this works. So I'm going to copy this and I will go to my remix. I'll create a new, no, not here. Okay, here I will create a new contract called Ovia token.sol. Don't forget that. Right? It's created a new contract for me. I'm going to paste this, giving me a warning about pasting it. And let's see, it is already compilation is successful because I have put auto compile over here. Okay, let's see, any advanced configuration, do we need it? Right, okay. We can enable optimization. It's not, optimization will just help you reduce a little bit of gas while deploying the contract. So it's good, let's compile it. So while on compilation, we have 2 outputs, one ABI file and one bytecode. The ABI file basically tells you, it gives you the signature of the functions and variables that you can use. So let's deploy it. So I want to deploy it in on the Sepolia test network. I've connected to my injected provider MetaMask. So the MetaMask has 0 Ether because I'm connected to the mainnet. Let's go ahead and connect to the Sepolia test network. And I have 0.99 Sepolia ETH. Let us connect back. Yeah. So now MetaMask has recognized that I have 0.9 and I've changed the network. And let us deploy it. Then immediately it is asking me for to sign the transaction, deployment transaction. And I've signed it. And it's going on. And I think it's done. So let us see this transaction on Etherscan. Right? Cool. So it's a contract creation. It is happening. And so it'll get confirmed, as I said, when the next block on the blockchain is created and the transaction is finally entered a block. Okay. Cool. It's done. And we have a contract address. Let's go to this contract. So this is
our... sorry.
Yeah.
How did you get it to pull up on Etherscan?
Okay. So you can go to MetaMask and you can see the latest transaction over here.
Oh,
okay. This transaction and view on Block Explorer. This is one way to do it. Or you can go to Remix. Remix also has the deployed Ovia token here. Can you see? And can you see this view on Etherscan link? You can also go via this. Or another way to do it is to just take open this transaction and a transaction, here, deployed contracts, right? You can just copy the address of this contract and go to Etherscan and search with that.
Okay, perfect. Thank you.
Ways to find this transaction, this contract on Etherscan. So once you've created this contract, let's try and verify this contract because we failed to do it last time. So let's do it. Let's do a verify. So the compiler types, let's go back to our remix and let's see what compiler we used. Yeah, so I think Remix used this 1.18 plus commit. Let's see. So it's a single file. Okay. Compiler version is 1.18. Open source, we're going to do the MIT license. And let's click on continue. Right, we did do an optimization, yes. So let us, so in Remix, we can, let's just see if there's an extension or something available for this. Flat. I think that is flat. I don't know what that is actually. So because we have multiple files, we need to put them all into the same file. So that's what I'm. It's not a local plugin. Just gonna quickly Google this. Okay. Yes. Let's try this. Oh, okay, cool. Let's try if this works. Yeah, cool. It's flattening. And the flatten.sol is available. So I can just Control A, Control C this, go to my this thing and paste it here. Okay. Now this is not there. So what do I do here? Open my, let's see if I can see this. This is my contract, right? This is the transaction that basically got the contract. I'm going to take this code. And put it here. I don't think I should put the whole thing. A little bit. Okay. So let's see what the difference is. Okay, I'm just going to open a notepad. Let's open a notepad. I'm going to do a move file. Okay, this is a lot. Let's just try with this and see what happens. I'm not sure it'll succeed, but yeah, but this is the method to verify. Where is it? This is the method to verify. So I'm just going to keep my fingers crossed, but I'm not too hopeful. Okay, this is the constructor arguments for the contract of constructor parameters. Okay. So basically you have to take the exact constructor. Maybe this was too complicated or thing to show. Maybe let's take a simpler one. Let's take storage, for example. Let's deploy this in our, just to show you that it's possible to verify. I'm going to do this. So I'm going to deploy it. It's going to ask me for MetaMask, confirm. It's done. Let's view on Etherscan, right? So Ethereum, it takes about 30 seconds for it to get finalized. So okay, this is the transaction. This is the contract. I'm going to verify the contract. Oh, okay. Wait. See, the bytecode came here. Let's see if it is possible. Okay, so 8 single file, pilot version, this, and it is the GNU 3 version, right? Let's continue. And we didn't do any optimizations this time. No, we did do the optimization. So let's go here, say yes. Then why is it not showing this?
She was off.
Sorry? This is the deployed bytecode, right? I think I'm going to get back on this. I don't want to waste too much time. But yeah, coming back to our Ovia token, it is possible to verify and publish, guys. Please take it from me. I've done it before. I'm not able to do it again. But what verify and publish does, it's a very Etherscan specific functionality. You can do read and write contracts like you do in Ethereum. So for this, let's go back to our other deployed. So the Ovia token, if I can do these read and write functions, right? And I could have done it even on Etherscan. That is the only difference. So as you can see in my Ovia token, we only wrote one function mint, and it's a constructor, but we have so many functions because we were able to import from all of these things. So if the balance of, so if I check balance of my account, which is FDA, this thing, it should be 10 to the power of 1000 into 10 to the power of 18. So let's check balance of, yeah, can you see? There's a lot of zeros. Also, I can transfer. If you have a Sepolia, if you have an address on Sepolia, please drop me your address and I will send some of my tokens to you, and we will see how to do that also. Can somebody drop me their Sepolia network, just their MetaMask address on the chat? Does anybody have their MetaMask address? Cool. Let's send some of my tokens to Makai. So this is I've just copied her address. She's put it on the chat. Copy. So now I'm going to do a transfer of this tokens, right? So I'm going to transfer it to this address, and I'm going to transfer how much? I'm going to transfer, let's say, 5 million. All right, this is millions. Yeah. Okay, I'm going to transfer this much of my tokens to Makai, and I'm going to execute that transfer function. It's going to ask me to sign it, and I have to pay some gas fees. I'm transferring the OVT token. It is not a native transfer. So I'm going to confirm it. And it has gone through. Let us check it out on Etherscan. It's going on from my address, which is FDA7. You can see my address over here. It ends with 10E7. And to Makai's address, which ends in 92C2. Okay, this is the token contract. The contract that I interacted with. And the token transfer happened to 92C2. How much? I transferred this much of Ovia tokens. So let us see that. And if, as I said, this is not a value transfer, it is a function invocation. So you have the function transfer was invoked in the contract, and this is the signature of that transfer function. And I passed in two parameters. First parameter was Kai's address, and the second parameter is the hexadecimal value of the value that I transferred. And if you see the other parameters like value is 0 because this is not a native transfer. This is the point to note over here. So now how can Makai see my tokens in her MetaMask, right? Makai, I've already sent it to you, but you won't be able to see it because you have to import my contract on your MetaMask, right? So let's help you do that. I'm going to do it first and then we will help you do it. So here, if you go to MetaMask, there are several tokens, NFTs activity. In tokens, Sepolia ETH is automatically given to you because according to this, on the Sepolia ETH network, that is your native token. You can import a token. How to import a token? You can just basically, you can copy the contract address, right? So I'm going to paste the contract address here on the chat box. This is the contract address. Contract address and your address looks very similar because both are Ethereum accounts. Ethereum accounts are of two types, externally owned accounts and contract accounts. They have very similar looking addresses. So I'm just going to copy this address, open the MetaMask, go to tokens. I'm going to import a token with the contract address here. Okay. And automatically it was able to recognize that this is the OVT token with the decimal of 18. So I'm going to add this token, import it, and it knows that I have this much remaining 9999. So if I import it, so MetaMask is able to track my ERC20 token. How cool is that? So Makai, I would like you to share your screen and do the similar steps, and we can see how much OVT token you have.
Okay, great. Let me. Oh, it says I can't start screen sharing yet. Oh, probably because.
Can we enable screen share for okay? Bhavya? Okay, let me see if I can. Maybe I can stop the screen sharing and then.
Oh, okay, let's see. I'm not sure. Oh, yeah, I see it now.
Okay.
Really? Okay, I'm not sure how to find, I guess, the transaction that you just created.
You don't need to find my transaction.
Oh, okay.
So all you have to do is open your MetaMask. I've given the contract address to you. You can go to import tokens. Import tokens. Paste the contract.
Is it in the chat?
Yeah, on the chat.
Oh, cool.
Yeah, it was able to recognize that it's OVT. Add the custom token.
What's this token decimal? Is that...
So the lowermost denomination of this token.
Oh.
So you have so much, it's 0.000, but yeah.
Awesome. Import.
Yeah.
So and then it shows up.
Yeah.
Oh, cool.
So you have, so you can create, so any tokens that you have in your portfolio are basically written like this. Anything like Bitcoin, or if you have it on the Ethereum chain, this is how it would be written. So in a matter of 5 minutes, we were able to create our own token. How cool
that was fast.
Right? Okay, so thank you, Makai, for helping us with this demonstration.
Yes, thank you.
I'm going to share my screen again. Yeah, so let me quickly, okay, I want to wind up now. Let me, okay, so we saw how to create a ERC20 token, and using this wizard that we just saw, which is the Open Zeppelin wizard. Where is it? Had it open, right?
We're seeing your desktop, I think.
Okay. Can you see? Can you see now?
Yes.
Okay, cool. So using this Open Zeppelin wizard, you can create anything. We saw how to create a ERC20 token. Similarly, you can create an ERC721 token. You can create a ERC1155 token also. I'd like you to play with it. It's fairly easy to do, and you can directly also open. So I copy pasted it, but you can also open in Remix directly, or you can download and save it as a solve file. Yeah, so this is a very cool and easy feature by Open Zeppelin. If you want to know what these contracts do, what all the library contracts that Open Zeppelin has, you can go to their GitHub and go through the contracts, right? So this is the GitHub page for Open Zeppelin. So you can go to their contracts. They have token contracts. In token contracts, they have ERC20, ERC721, and ERC1155. So this is basically where these imports are coming from. These imports, right? So you can even follow this path to find these contracts. So you can see how each function is implemented. All the functions that we talked about. Name is just a return name, symbol, decimals, total supply, balance of, transfer, allowance, how they're actually implemented. Please go ahead and see them. Another thing I wanted to mention is, yes.
Ovia, in GitHub, which I see they have a lot of different repos. Which one were you in?
So there's Open Zeppelin contracts. So the Open Zeppelin, if you open, this is the Open Zeppelin hub. It has a lot of contributors. You would want to go to the Open Zeppelin contracts. Under contracts, if you go to token, so basically after you come here, you can just follow the path in the import.
Oh, I see. Okay, awesome. Because it's coming directly from them. Okay.
Yeah, it follows the same tree. So you can go to contracts, token, and choose. We used ERC20 just now. Yeah, and you can understand exactly how each function is implemented. It's fairly easy to understand. So basically, they have a couple of state variables and some mappings. A mapping is from address to the balance is the balances mapping. Address to integer gives you the allowances. That is, this address has approved this much allowance for this address. So this is the spender and this is the owner. So this is for the allowances array. There's an integer for total supply, name, and symbol. So again, the constructor would be simple. It's just a name and a symbol. You have a name function that will just return the name. A symbol function just returns the same. Let's look at something a little more complicated, like say transfer function. So you would want to transfer to this address this much value. So what would you do? You have to change the balance of you have to reduce the balance from the sender and increase the balance in the receiver, right? So obviously the person who has invoked this function is the person you want. That was the owner. And it's calling an internal function transfer. Let us go to that function, internal function. Yeah. So the internal function, okay, it's basically doing a little bit. So it's saying that if it is an invalid address, you would basically return an error. You have to check that both addresses are valid. And then it is internally calling an update function. The update function would just check, it would reduce the value from the sender and increase the value in the owner. And if it also checks if you have enough balance to send, all these conditions, right, is taken care of here. And finally, in that balances mapping from for the from address, from the existing address, you're subtracting that value, and for the sender, and to the to address, you're adding this value. That is basically what transfer does. And finally, you have to emit the transfer event. So this is how the transfer function works. Yeah, so it's very simple to understand. So I don't think there is anything to really think about. So approve is basically you're just changing the mapping, right? You're setting it's a two-dimensional array. For this owner, for the spender, you're setting this value as an allowance. Yeah, that's pretty much it. So I hope you enjoyed this course, and there's so much more to learn in Solidity. I've tried to cover a bit like beginners to intermediate level, and in the process, I hope you enjoyed and started appreciating this whole field and this language. If you want to develop hone your skills further, I highly recommend you go through this doc, which is the official Solidity documentation. It has a page called Solidity by Example, where it takes you through 5 major applications. Voting will be very similar to the ballot contract that we developed in the last week. There is also a blind auction, which I kind of suggested last week that you do as a practice. And there are safe remote purchase, micropayment channel, modular contracts. So these are some examples that this official documentation gives that you can go through, and they're very good. But if you think that these examples are not enough, a very good website is soliditybyexample.org. I'm going to put this in the chat box. So here you have it explained in the most simpler. You even have a video. So this is an open source. The community has developed this website where you can go line by line. So most of the code that I used for this bootcamp was from the Solidity by Example. You can go through if you want to understand the structures of Solidity, you can go through the first part, which covers your basic mapping, enum, structs, all of that. And if you want some applications, if you want some real-time use cases, you can go to some of the applications for this thing. So this has your Dutch auction, English auction, voting. It has your some DeFi examples also. It also takes you through Uniswap, how Uniswap contracts work. So let's go to Uniswap, for example. So this is a sample Uniswap V2. Uniswap has got migrated to V3 right now. This is an older version. But what a DEX does is, DEX is like a DApp. So they have deployed some contracts that lets you swap one token for another token. It's think of it like a foreign exchange. You go with your dollars and convert it to euros, maybe. But this decentralized exchange lets you swap cryptocurrencies. It does not let you swap real money to crypto or crypto to real money. But if you have a crypto, you can convert it to another crypto, be it native or ERC20. You can swap it, right? So let's see how. So this is okay. So a DEX will host multiple pools. Each pool is formed with 2 tokens. So if you're going to swap, let's say, wrapped ETH to DAI, you would go to the pool that contains these 2 tokens, right? So let's see if there's a simple one that we can take. So again, this it extends from an ERC20. So let's take a single swap exact amount in. So they have different swap functions. So where they want to swap either from the wrapped ETH to DAI or DAI to wrapped. Okay, this is only for wrapped ETH to DAI, I think. So it takes the amount in and the amount out minimum, which means that so the pool decides the rate at dynamically. So based on the amount of tokens left in the pool, your rate of how much you get in return for one token is decided dynamically. So amount in is how much of wrapped ETH you want to put in, and amount out minimum is how much minimum amount of DAI you expect in return for your wrapped ETH. So it cannot go below that, right? And it will basically return the amount out, how much you want to, how much of DAI you're getting in return for the wrapped ETH. So, so here, what this line does is it takes, so from the wrapped ETH contract is also an ERC20 token. So it's invoking the transfer from function from the message.sender to this in the amount of, so address of this is the way you can, this is the current contract, which is this Uniswap v2 examples dot contract, and it is basically typecasting it into the address data type. Yeah, so transfer from function is the person you're transferring from, which is the message dot sender, and the person you're transferring to, and the amount it will. I think this is a very old example. That's why they've written it like this, because this is not how you do it now. Let's directly look at Uniswap v2 on GitHub, because all of this code is open source. So you will be able to, yeah, let's see. Cool. Let's go to, so this is, I was just able to find Uniswap directly like this. So this is the pair. So this is the pair that I was telling you. So this is a generic one for all pairs. So any two tokens can be a pair on Uniswap v2. So if you see mint, burn, so they also have a concept called LP tokens. So once you add some money, they'll give you a token return, which is also an ERC20. So token 0 is the first token in this pool, and token 1 is the second token in this pool. And they're all addressed because they are individually a ERC20 type. So they have an integer amount of how much of token 1 is there in this pool and how much of token 2 is there in this pool. Both are integers. So let us see if swap. So okay, this is an event swap. So whenever a swap has happened, a swap function is invoked, you basically emit this event. Let's directly go to the swap function. This burn. Yeah, there's a function called swap. So it basically takes in, so low level function is on. Okay. So the person you're swapping to and what amount you want, basically amount, how much of amount of 0 you're for token 0 you're giving in, how much amount of token 1 you want out. So it should return some value. Okay, so it's just updating the balance in here. It's not, so this is an internal function. So we should look for the function that is user facing. Okay, but I think we should still be able to understand this one. So first, it just give me a moment, guys. Okay, I'm not sure why it's asking for both the tokens. So if you see here, so it's expecting you to input the amount of token A and token 0 and the amount of token 1. And it's first checking that both the amounts that you want is greater than 0. Insufficient output amount. Okay, I think I have done another video on how Uniswap works. Maybe I can share a link to that. This code just seems a little bit off to me because it is taking two amounts as inputs. Swap should ideally take only one input and return another amount as output. So I'm going to find that code and share that link. And of course, Uniswap has moved to V3. So yeah, it'll make more sense to just read the V3 code. Let us see if we can do that. and see if the swap function changes a little bit, maybe. See, now they've called it a pool. And in this pool, let's quickly go to the swap function. So find it. There are too many. Yeah, all of this has changed so much since I last saw it. Okay, this is the function swap, where there is a recipient, the amount that is specified, and that's it. The price limit is how much of the other amount you expect in return. But it is changed a lot, so I don't think we can go through it right now. But I'm going to find the other video and share it with you guys. So I think we can call it a night. Again, we've exceeded far beyond our time. Bhavya, are you there? Oh, this is a nice one to look at. So this is the factory that creates a pool. So every time you have two tokens, you would want to create a new pool, right? That's what this contract does. And they have a nice create pool function where they are specifying the two tokens that you want to create a pool for. And so here you are checking basically whether both the tokens are not the same. And then you're basically assigning token 0 and token 1 value. So this is done so that you always get the same order. So even if somebody wants to, let's say USDT to DAI or DAI to USDT, they come to the same pool. And token 0 is always assigned to DAI and token 1 is always assigned to USDT based on their order, like D is smaller than U. So this is the step for that. Again, they're checking if it is non-zero address. Dict spacing is a concept that's a very DeFi related concept. So let's not go there. So yeah, so now they have to create a pool, right? So first they have to check if this pool doesn't already exist. For this token A, token B fee combination pool does not already exist. So they should have they already have a mapping for pool. So they're just checking whether this pool is zero address right now. That means it does not already exist. If it does not already exist, then they're creating a new address with all of these parameters. So the parameters will help in creating a particular address, and then they're adding it to the get pool, right? And they're adding it to the pool, and they're also adding a reverse mapping. So token 0, token 1 fee is also added. Token 1, token 0 fee is also added to this mapping, and then they're emitting the event that pool is created, right? So this contract is relatively much simpler. I haven't gone through the other contract, but I will do so. Right. Bhavya, are you there?
Yes, I'm here. Yeah.
Okay. So yeah, I was just going. So I was trying to see the Uniswap V3 factory, but I think they've changed the code completely, so it looks a bit new to me. I've done an older version, so I'll share the video of that and you can circulate it. But apart from that, we've covered the major topics, I think. I'm happy to take questions and can end the session.
Questions? Yeah. In case there are any questions, feel free to drop them in the chat session. later, if you get any doubts, you can also connect to Ovia over her socials, or you can drop a message in the Slack channel. We have all of the social media links for Ovia mentioned in the Slack channel as well.
Yeah, there's a question by Leila. She's asked, this was my first session. Would you like to please share what other tech stack do you work on or have used in addition to Solidity? So Solidity is Ethereum specific. It will work on smart contract development for all EVM based chains. But yes, this field is constantly changing, and there are new blockchains who've developed their own languages to create smart contracts, and that they believe solves a specific purpose that Ethereum basically lacks. So to be ahead of this tech, to be on the bleeding edge of this technology, you will have to keep adapting and keep learning new stuff. I highly recommend learning Rust. Rust is a very good language that Solana, Cosmos, many blockchains are built on, and there's a specific smart contract. So Rust is a normal language like C or C++, but the smart contract, there's a smart contract language that is based on. There are several smart contract languages that are based on Rust. One of which is Move, which is used by this layer 1 blockchain called Aptos. There is a language called Cairo, which is used by, that's also based on Rust, that is used by Starknet, which is a layer 2. And there are many more. But yeah, I think other than Solidity, it would be really good for you guys to do, learn Rust. But there is a lot of demand for Solidity developers. So this is also a really great tech to master. So we have definitely not mastered this. We have just covered the intermediate. There's so many advanced topics to learn. But with all the constructs that we've seen in this bootcamp, you should be able to make sense of even advanced, at least line. If I can give you a line of Solidity, you should be able to understand what that line does and how it relates to the overall contract. I've dropped my socials, I think, in the chat, and Bhavya also has them. So you can reach out to me at any time, and I'll be happy to even maybe schedule a one-on-one session if you require it.
Thank you so much. This was great.
Thank you. Thank you.
So much fun.
All right. In case we don't have more doubts, we'll close for the day. Thank you, Ovia, for the amazing sessions. It was really great learning experience for all of us. And we would definitely like to have you over for another event. Thank you all for following through. And in case you have any doubts or questions, you can join the Slack channel as well.
All right. Thank you, guys.